All right, the last day of Unit 5, Law of Cosines. So this guy, the proof for this might be kind of confusing. So without really trying to force it on you, I'm probably going to pause and do a lot of writing in between. So at the end of it, if you don't fully understand all of it, but you at least understand like there is something behind this, it is real, it's not just made up, that's kind of my goal here. So our learning target at the end is to find the missing triangle, side lengths, and angle measures using the law of cosines. And basically, you want to use the law of cosines when you can't use law of sines. I think law of sines is just more, it's probably easier, more straightforward. And if you can use law of sines, you should probably use law of sines first. So, first off, to try to make it simpler, I think this picture is not great. I wish I wouldn't have chosen that. I'm gonna draw it like this. And all I did is I took point C and I moved it out. I moved it out of way so it's over here somewhere. And looking at this guy, so these would be true. So the cosine of A would be x over b, which x would be the distance right here. So this is x, and this distance right here would be, this would be x, this would be y. So this is a coordinate C is x, y. So this would be x, this would be y. X is shorter than C, and y is going to be shorter than A. So they're not quite the same thing. And sine of A would be y over b. So using that idea, keeping that in mind, I want to find the length. I'm trying to find the length from C to B, which is A, using Pythagorean's theorem. So I'm going to say A. So A squared is going to equal, and it's going to be B squared plus C squared. Well, B squared on this one would be the difference in the x's. Okay, so here's my x's. I got this is over x units, that's over c units. So how far apart are they? Well, I say x minus c squared. So that's a change in the x's plus the change in the y's. Change in the y's would be from y. Why did I put that? I put xc. That should be xy. From y to 0. So that'd be y minus 0 squared. Now keep in mind that over here x would be b cosine a and y would be b sine a. So I plug those in for x and y, and since this is minus 0, that's really just y squared or b sine a squared. Now I actually square these. So if I actually square these out, so I'm going to FOIL this guy out. Okay, so I get this. And then if I see I have this guy and this guy, I'm going to put them together first. Okay, so I change the order, and then if I factor out a b squared, so I take out a b squared, it'd be cosine squared a plus sine squared a, which is going to be 1 minus all this stuff over here. So rearranging some of the order, so I'll just do this and say that's a 1. I've got b squared minus 2bc cosine a plus c squared. I'm going to bring the c squared up here, so it'd be b squared plus c squared minus 2bc cosine a, and that equals a squared, and that's actually the first law of cosines. Okay? And you can just switch the order. So as long as this side and this angle are opposites, it doesn't matter which one's A, which one's B, which one's C. It's just that this angle and this side have to be opposite each other, and then these are the other two sides. Okay? So, we say A, B, C. It could be C, B, A, and then that would be a C over there. If this is a B here, that's a B there, and so on. So you can do this if you know two sides and the angle between them. So you have two sides in the angle, so side, angle, side, which was not covered with law of sines. You couldn't do that. Or if you know all three sides. So if you just have side, side, side situation, you couldn't use law of sines, but you can use law of cosines. Okay. So the big thing about this, you got this picture, you got a racing committee who wants to lay out a triangular course. Sounds like a pretty crazy turn. You have to slow way down the turn. This side is 3.5, that's 2.5, was a length of the third side. So if I'm trying to find A, and I couldn't use law of sines because I don't have any pairs of angles in the opposite side. I don't know them. So the law of sines is out. I'm stuck with law of cosines. So I'm trying to find A, so that'd be A squared equals, and then I'll stick with B being 2.5 and C being 3.5, but it doesn't matter if you switch those. So that equals 2.5 squared plus 3.5 squared minus 2.5 times, 2 times, so 2 times 2.5 times 3.5 cosine of A. cosine of 40. Okay. Now when it's written like this, you can type all that in the calculator at once. So if you type all this into the calculator, it's about 5.094 roughly. Leave that in your calculator and square root it. And this says round to the nearest tenth, so this would be about 2.3 miles is the other side. And that seems realistic, that that fits in with the other ones. This isn't an extremely large angle, so it should be about the same as those. The other situation is when you don't know any of the angles, so that means your variable is going to be this guy over here, this A. So let's see, find the measure of the angle opposite the longest side. So I'm going to try to find the angle opposite 15 first. I have to know that because that's the side that goes by itself. That's the 15 squared here, and then 10 squared plus 14 squared minus 2 times 10 times 14 cosine A. Be careful on this. A lot of students, they think I type all of this into the calculator and then divide it over. But this is being multiplied by cosine A. This is basically added. Think of it being subtracted away from. So when you're doing this, I would stick with this chunk and that chunk. Simplify them first. So 10 squared plus 14 squared is 296. Well, this is 225 over here. You can simplify that too. Minus 280 cosine A. Again, you have to subtract 296, but divide by negative 280. I can't subtract those together. A lot of people get in trouble and they put 16 cosine A. That's not the same. You can't subtract those. This is being multiplied by cosine A, and this one's not. This one's not, and this one is. So I'm going to subtract this over first. You might be thinking, uh-oh, I got a negative over here. That's okay, because I'm going to divide by a negative here to get cosine A by itself. So I'm going to divide both sides by negative 280. So A is going to equal, cosine A is going to equal this ratio. You can just put 71 over 280. Then do inverse cosine of 71 over 280. So A, in this case, when I round to the nearest degree, is 75 degrees. Okay. There's really no ambiguous cases here to worry about, thank goodness. It is what it is. Some other formulas now. You got Heron's formula. This is for finding the area of a triangle. It's just another way of finding it. We showed you one yesterday. This is another way of finding it. What you need to do is you need to find what's called the semi-perimeter first. I think perimeter is the area all the way around. Semi means half, so it's just half the area all the way around. That equals S. And that's what you're going to plug in here and square root. Okay, now that only works if it's a triangle. Because sometimes we give you three sides, and if I gave you some toothpicks and said make that a triangle, it wouldn't work. It wouldn't reach. The sides would not reach to each other to close it up and make a triangle. So there's this triangle inequality theorem where the sum of any two sides must be larger than the third side. So if you're worried about whether or not it's a triangle, you really only need to check the two smallest sides. So I would say check first the smallest plus the medium, and make sure that's larger than the largest, the biggest. If you check that first, if it is, then it works. Because then, if that is true, then the medium plus the biggest will be bigger than the smallest, and it has to be true. So if this is true, they all three have to be true. So before you try to find the area, make sure it's a triangle. So this guy here, check the two smallest. 28 is larger than 18, that's good, because the two smaller sides have to be larger than the third side. So now it is a triangle, let's do Heron's formula. So first I need to find out what's my semi-perimeter. So I'm going to take 13 plus 15 plus 18 and divide by 2. And that gives me 23. So now I'm going to take the square root of 23 times, and then now 23 minus, 23 minus 13, 23 minus 15, and 23 minus 18. And if you really want to, you could type in the calculator just like this. So you just type it in straight in the calculator, exactly the way I got it written. It equals, you get 95.91. It doesn't say where to round it, so I'll just say 95.92 units squared. Okay. Now look at the one below here. It says I got 5, 6, and 12. Now you could just jump right in and try to find the area, but first make sure it's a triangle. So if I put these two here, this two smallest, 5 plus 6 is 11, that's not bigger than 12. So what happens is you have this big length here, and you got these two sides that these two combined aren't even as long as the third side, so it never closes up. It never comes together and makes an arch. So this one's not a triangle. Can't do it. So nothing to worry about there. So hopefully that helps. It's kind of fast, kind of a short lesson, but I think you have some experience with law of cosine, so just got to refresh yourself on that.